are the values of the domain? Hadley, what are the values? -2, 3, and 5. And we would put that in what we call set notation. So you don't just list -2, 3, 5. You need to do the squigglies, -2, -3, whoops, not -3, -2, 3, and 5. So for this relation, this group of numbers that we have, these pairs of numbers, the only values that are allowed as our x values or our input values or the domain are 2, 3, and 5. Hold on. Okay, so let's talk about the range. What are the values for the range, Talon? One, 2, 7, and 8, and the proper form is to put it lowest to highest value when we're stating domain and range. So this again, the range is the output, the only allowable values for the output or the y coordinates for this group of numbers. And the set of numbers or the ordered pairs that we have, we call a relation. So for this specific relation, those are the only y values that are allowed. And that's why they're called the range. How did we get those numbers? I gave them to you. I created that relation. I just created it. So there will be other times when we have specific relation or specific based on a word problem or a function rule that we have. And there'll be more values, but for this, these are the ones that I chose. So is the relation a function? Gabby, what do you think? No. Why not? Okay, so one number in the domain has two separate range values. Okay, so 5, that's 5, has 2 as a range value and 1 as a range value. So if that's the case, that is not a function. In order to be a function, each input value can only have one output value. And here 5 had 2 output values, 2 different ones. So, all right, there we go. Let's go to our notes and let's add one more. Okay, sometimes we are only given the graph of a relation. We're not given the mapping diagram. We're not given the list. We're not given, what would be the other thing? Mapping diagram, the set notation. We're just given the graph. And we can do what's called the vertical line test to see if it's a function, see if that relation is a function. And if it passes, it is a function. If it doesn't pass, it's not a function. So what is the vertical line test? So the vertical line test is if you pass a line, vertical line, that's up and down, through your graph, and it doesn't touch the graph in more than one place at a time, then it is a function. So, for example, let's look at this graph. Okay, so that's the graph of a line, right? And that's a set of numbers infinitely. There's a whole bunch of points that make up that line. So the vertical line test means, I'm going to draw a vertical line here. If we were to, move that line, here we go. If we were to move that line across the graphed line, and notice how it's only touching the graphed line in one point at a time. So this would be an example of a function. Okay, so on, again, this graph is not a function because for this x value, there are two separate y values that go to this graph, and it doesn't therefore pass the vertical line test. So here we've got a set of 5 points, this point right here, then this point, that point, that point, and that point. Does it pass the vertical line test? Can you tell already if it does? It passes? Okay, so it doesn't, because as we go to this point right here on that vertical line, that's the only point that is on the vertical line right here. As we move our vertical line, hopefully I can move that, yep. We go to this line and it crosses those 2 points on that same vertical line. So that's why it's not a function. This point's okay, that point's okay, but if we have any place on our graph of points where it crosses the vertical line, 2 of them cross at the same point or same vertical line, then it's not a function. So again, this one would not be a function.